Okay, so the second topic, different. It's also solved. But it's solved by multiplying by a common denominator. So this is another multiplying technique, and it's a technique that allows us to get rid of fractions. This technique is probably a little bit stronger than common denominators. You can use it in more situations. Than cross multiplying. And cross multiplying can only be used in very specific situations, but multiplying by a common denominator we can use in lots of situations. And I get tired of writing the word common denominator. It's got a lot of variables. So I will write this, common denominator, mostly because I'm lazy. Okay? And the time that we're going to multiply by common denominators will be when problems have lots of fractions in them. Now, I'm going to have you put your calculators away. Okay? Okay? You have to put your calculators away. Honestly, if you have your calculators, this method is not a lot faster. This is a good method to use though when you're not allowed to use your calculator, but you won't be allowed to on everything that you do. So we're going to do these problems without our calculator, and then I'm going to let you get your calculators out to check your answers, okay, at that point, for your homework. All right, so the first thing I need you to recognize is that this problem does not have one fraction on the left and one fraction on the right. Instead, you have two fractions on the left. This is a fraction, and this is a fraction. So when the problem looks like this, you cannot multiply, you cannot do cross multiplying. That's not going to be one of the things that's available to you. So it's an option. Okay? Instead, what we're going to do is multiply the entire problem by the common denominator. Now, a lot of common denominators are super easy to get. Yes? Like, what's the common denominator for 3 and 2? 6. No one has a problem with that. But I'm just going to show you a way to get common denominators so that when they're a little harder, you know how to do it. Take the biggest denominator that's there. The biggest denominator that's there is 3. And start a list of the multiples of that number. So give me the first few multiples of 3. 3, 6, 9, 12. Usually, in this class, I'm not going to have you go up more than 3 or 4. And then just start at the beginning and find the smallest one that the other denominators go into. Okay, so does 2 go into 3? Nope. Does 2 go into 6? Yes, and there's your common denominator. And that will work even when it's one that you don't see right off the bat. Okay? So common denominator is this. So here's what this is going to look like. You're going to take the left side, put it in parentheses, and put times 6 on the outside of it. Okay? Put it in parentheses, and put it times 6 on the outside of it. You're going to take the right side and put it in parentheses, and put it times 6 on the outside of that. We are multiplying both sides of this problem by 6. This is going to change all of the values, but it should get rid of all of the fractions for us, okay? Now, the benefit of common denominators is that even though we're dealing with fractions, it should be easy fractions. By choosing common denominators, it should make things easy, okay? So, for example, right here, this is going to be 6x over 3. Yes? What happens to 6 and 3? 2. It becomes 2. That's easy. Minus, right here, what's 6 times 5? 30. And I get 30 divided by 2. That's easy. What's that? 15. Okay, by choosing common denominators, you end up with some easy fraction arithmetic. And the other side's not even a fraction. Negative 4 times 6 is negative 24. If you have chosen a good common denominator, and if you do your multiplication correctly, you won't have any fractions after you do this. That's a pretty big benefit. Yes? Pretty big benefit. Okay, so let's finish this problem. Oh, no calculators. Can you do this without your calculator? Sometimes I get out my fingers and count. 15 up to 24. I think it's -9, isn't it?
Yeah.
Yes.
It is.
Okay, -9. Now, I told you that when you multiply by common denominators, you get rid of fractions. What I cannot promise you is that they won't come back again, and this answer has come out to be a fraction for an answer. Now, I am going to ask you to do these problems without your calculator, and then I'll tell you that you can get your calculators out to do your checks at the end, okay? All right, so this has been some good practice with fraction arithmetic, but also give us a chance to practice our calculators as well. Yes, ma'am.
For checking, can we change that into a decimal?
As long as you don't round it. So this is gonna be a 4.5, maybe 4.5, that'll be fine. Okay, so here's our second problem. Now, some of us are really good at common denominators, and some people need a little bit of help figuring out a common denominator. So I'm just gonna, again, show you my technique for figuring them out fairly quickly. Take the biggest denominator that's here, which is 5, and start listing multiples of 5. Y'all can, multiples are easy, that's just counting by, yes? Okay, is 10, 15, 20, usually 3 or 4 will be enough. And then check the other denominator and see if it goes into 5, no, 10, 15, and 20, yes, and if it didn't, just do the next one and it probably will, okay? Now, you don't have to do that every time. Sometimes you look at them and you can just see the common denominator, agreed? But this is a way to get it, okay? So, what you're gonna do is you're gonna take the problem, you're going to put parentheses around the left side, and you're gonna multiply the left side times 20. You're gonna put parentheses around the right side, and you're gonna multiply the right side times 20. And I want you to stop after you write that down, okay? If you have chosen a good common denominator, then the next step should be even easier than I showed in the last one, because something's going to cancel for every single fraction, every time. There's no fraction here, so you're gonna write down a 20. But right here, what cancels with a 20 and a 5? What does it cancel to? 4. Y'all see that? So this is gonna cancel, this and this will cancel, and you'll end up with 4 times 2x, and 4 times 2x is 8x. Now, you can also go ahead and say 20 times 2. Okay, but this is a shortcut for that. It's going to cancel, guaranteed. Look on the other side. What are the 4 and the 20 cancel to here? What's that going to cancel to? A 5. Don't have cancel, yes? Yeah, and 3 times 5 is 15. This is going to happen every single time if you have chosen good common denominators, okay? It makes the fractions go away, and it makes the arithmetic easy. All right, what's next? Subtract, correct. Minus the 20. Don't lose your negative here. Negative 8x. And once again, even though we eliminated the fractions at the beginning, sometimes they come back at the end. Okay, because sometimes in real life the answer is fractions. Try to remember that negative divided by negative is 1. Okay. Two things they learned this method last year. It's going to be useful in some of the things that we do in Algebra 2 as well. Okay, this time my left side has 2 fractions and my right side has 2 fractions. Okay? I have to get a common denominator for every single fraction that's there. Okay? Again, some people can see it very quickly. Some people need a little process to get there. But the technique I showed you will work for this. The biggest number is 10. I'll just write down a few of them, 10, 20, 30. And then start with the first one, 10. Does 5 go into 10?
Yes.
Does 10 go into 10? Does 2 go into 10? And the first one is dead. I don't need it anymore. You'll see? All of them will work. You can pick a bigger one and it will still work. So we're going to put parentheses around the left side and parentheses around the right side, and multiply both sides of those problems by 10. Girls, I want you looking at this and thinking about canceling. What cancels out? The whole purpose of multiplying by common denominators is to get these fractions to cancel, okay? It makes the arithmetic easier, especially when you don't have a calculator. But even when you do have a calculator, if I let you use a calculator to do this, it'd be even easier still. Okay, did you have a question, huh?
Yeah, so you only multiply the top, numerator.
Okay, there's two ways to look at this, okay? Make sure this answers your question. Okay, pencils down and watch. There's two ways to look at this. One, 10 times 2y is 20y over 5. So I think that's what you're asking me, top times top, not 10 times 5, just 10 times 2. Okay? Or, notice that when you say 10 times 2 over 5, that the 5 and the 10 are going to cancel. What are they going to cancel to? 2. And what's 2 times 2y? 4y. And do y'all see that that's what I get here? 20y divided by 5 is 4y. But I think what you're asking me, I want to make sure this is right and make sure that everyone understands it. You do not say 10 times 2 and then say 10 times 5. That's not how you multiply fractions. Okay? If you want to think of it as 10 over 1, then you can. But what our goal really is to get that canceling going so that we understand that this 10 and this 5 cancel. That becomes a 2, and 2 times 2y is 4y. That's what you really want to get to. Okay? All right? You ready to write that down? Yes? Okay, go. Then when I go over to this one, what's going to happen to this 10 and this 10? What do they cancel to? What? 1. Okay, they cancel to a 1, and 1 times 1 is plain old 1. Is that a frown? Okay. So let's try it on the other side, see if you can see how that's going to work. Everybody good on the left side? Yes? Okay, on the right side, you're going to take this 10 over here. It's going to cancel with the 2, and when it cancels with the 2, what are you going to get? 5. Does everybody see that? I'm going to drop that little 5 down there. 5 times y is 5y. Then I'm going to take the same 10 and multiply it right here with that. What's going to happen to those two 10s? Down to a 1, yes? And 1 times 3 is 3. See how easy that is?
Yeah.
Okay? Choosing common denominators makes the fractions easy to deal with, and it makes them go away, at least for a little while. All right, we've got variables on both sides again. What do you want to do? Yes? Question?
No, I can answer that.
Okay.
Well, I did, because I like having I subtracted 3 from 1.
You subtracted 3 from the 1, like this? Okay, that's a perfectly good thing to do. There were other choices that were also good. Okay, I'm kind of glad you did that. I'd like everybody to look at this and tell me what's the next best choice to make if that was your first choice. Subtract the 4y, because if we subtract the 5y, remember what's going to happen again? We're going to get that 0 over there, and that tends to mess us up. Okay, so we want to try not to get the 0 over there if possible. We are going to have to do that later on, but try not to do it right now. Minus 4 equals 1. And I still have a few people who forget that 1y is the same thing as y, but it is. Okay? Everybody feel pretty good about that? Yes? All right, I'm going to give you the next problem, and I want you to decide what to multiply by. I want you to multiply by it, and then stop. Decide what to multiply by. Multiply both sides by it, cancel, and then stop. Don't go any further until we can check to see that you have that right. Those of you watching online can do the same thing.
I'm sorry.
Yeah. Okay, so stop. common denominator for every single denominator that's there. It has to work for all three of them. Use the technique I told you. Pick the biggest number, write it down, make a list of the multiples, and then you'll be able to pick it. There's nothing wrong with writing a little work on your paper. You don't have to do all your work in your head. You found it. There you go. Hold on a second. And the common denominator is 12. And now do the next step and then stop. Let's see how you're doing that canceling step. Okay, now if you do this, you have to watch out because you gotta cancel that 12 over here also. So I don't like you crossing out when I'm doing this, okay? Watch what I do on the board. Okay, girls, watch. Right here, look. When I multiply, the 12 and the 2 are gonna become what? Look, no, not 12 times 3. That's a different answer. You can do it that way. But what cancels with that 12 and that 2? What do we get? A 6. If you do this, eyes up here, girls. If you do this, then you forget that you're supposed to still use that 12 again and multiply it times the 4. So I don't usually like to see that as a crossing out. I think that causes you to make mistakes. This 12 and this 2 are going to cancel, and you're going to get a 6 right there. Now, what's 6 times 3? 18. Okay. Then I'm going to do 12 and the 4 right here. Those are also going to cancel. And what are those going to become? 3. A 3. I'm going to put that right up here. And 3, this 3 times this 1 is going to give me minus 3x. Y'all see? Okay? Yes? Okay. So on the other side, 12, and then with that 2/3. So the 3 cancels with the 12. And what does it give you? 4. Everybody see that? And 4 times 2 is 8x. And that 12 times that 1, nothing cancels because it's a fraction that's going to give you a plain old 12. Are we good? Okay. Go ahead and finish that problem. We're going to practice that canceling step a couple more times. Okay, after y'all finish this problem. There's lots of different paths to this. Yours doesn't have to look exactly like mine. We do need to end up with the same final answer. And I got the answer 6 over 11. If you did not get that answer, if you would mark it please with a star, and I'll come look at it in a minute, okay, and see if I can find what we're going to say here. Now, before we go on, and there's a couple problems that are a little bit more complex, the basic process is the same, but we're going to do just a little bit more practice with just canceling, okay, just practice canceling. Okay, so draw a line, put a box around this. This is not going to be a whole problem. We're just going to do the canceling step, because that seems to be the place where we're running into a little trouble. that and just plain old adding. So, I can figure out that. Okay, so I want you to copy this down. So I'm giving you this step, don't worry about where it came from, and all we're gonna do is practice the canceling step. Okay? Okay, everybody ready? Okay, can you do the first one? Do the cancel, for the first thing, draw what you need to draw, write down what you need to write down, but only do the first one. I'm not gonna give you super weird fractions, these are all gonna be those things that are in your the multiplication tables, right here. 18 and 3, what does that cancel to? 6, does everybody agree with that? Yes? If you need to, write the 6 down right there. If you don't need to, don't. But then you say 6 times 2, and that gives you 12. Does everybody see how that works?
Yes.
Yes? Okay, now 18 again. Not the 6, but the 18 again, over here with the 6 at the bottom over there. What is that gonna cancel to? 3. Does everybody see? And 3 times 1 is 3. Okay, try the other side. The 18 with the 9 cancels to a 2. And 2 times 2 is 4. Yes? The 18 with the 3 cancels to a 3 into 18. 3 times 1 is 18, everybody. 6 cancels to a 6, and 6 times 4 is 24. Okay? That's just the I'm not gonna finish this one, because I'm not worried about y'all finishing it. Sometimes y'all get that right, sometimes you get it wrong, but I need to make sure y'all got the canceling step down. Yes? Okay, let's do another one, another practice canceling. And so this time I'm gonna let you figure out what to multiply by. I have to write so y'all can read my handwriting, this is tricky business. Copy the problem down, we're gonna figure out what to multiply by, and we're gonna practice cancel. Okay, so what's the biggest denominator? Everybody, biggest denominator, 15. Now, counting by 15 is not a lot of fun, but you ought to be able to handle it. 15 and then what?
30.
And then 45, and then 15 more would be 60. Just as long as you get 3 or 4, that's gonna be enough for what I have you do. Okay, does 5 go into 15?
Yes.
Yes. Does 15 go into 15? Yes. Does 10 go into 15? No. Okay, does 5 go into 30? Yes. Does 15 go into 30? And does 10 go into 30? And there it is. So what are we gonna multiply both sides by? 30. Everybody see? So sometimes you won't need to do that. Sometimes you'll see it.
What's the exciting news too?
Yes?
I love
I like to leave a little extra space here when I'm canceling. It gives me some room to draw those little arrows. Sometimes when we make our work really crowded, that causes us to mess up. And so putting one extra space in can make a difference. You are looking for what cancels. Okay? You're gonna cancel the 30 with the 5. What's that gonna give you? Ooh, one more time. 30 with 5 is going to give you 6. Okay. And you know, we're going to make those kind of arithmetic mistakes every once in a while. Just slow down and try not to make them. Okay. And then 6 times the 3 that was already there gives us 18. Okay. The 30 with the 15. 2. So right here is going to be a 2. And 2 times x is minus the 2x, right? Okay. On the other side, the 30 cancels with the 10 and gives you a 3. And 3 times 7 is 21. And the 30 is the 5, cancels and gives you a 6. And 6 times 2 is, so do you see how that really isn't hard? Its very nature makes the arithmetic easy. As long as I don't give you really horrible fractions like 17 and 43 and stuff like that. So this is about as bad as it really gets. Okay? Is that a little bit better on the practice with canceling? Okay. All right. Now back to a couple more solves. There's a couple of structures that are a little bit more complex. I don't remember what was the last one I gave you. Am I on number 5? Okay. It's kind of important that when you look at this problem, that you see that the left side and the right side are not the same structure, that they're a little bit different. The left side is one fraction, a single fraction, where the numerator's got a plus in it, but the right side is 2 separate fractions. Does everybody see that? Yes? Okay, so it doesn't make any difference except that this is just one fraction here. We need a common denominator for 2, for 4, for 8. Okay, what common denominator is going to work for 2, for 4, and for 8? 8. Okay, so again, 8 parentheses, and the right side in parentheses as well. And I always have a few people who kind of look at these two and don't see them as not exactly the same thing. I really need you to look at it and see they're not exactly the same thing. If you don't like this, if you look at this piece over here and it's causing you some anxiety and some trouble, there's something you can do about it. You can separate it into 2 separate fractions. Yes? Okay? You can take this fraction right here and change it into 3x over 2 and 1 over 2 if you want to. I'm not going to do it that way because I think it's easier without, but you can if you want to. Okay? So here we go with the canceling step. Ready? Yes.
If you were to choose the wrong, like,
Common
denominator, if you did like 16, wait, so 40.
If you choose a common denominator that is correct, it will still work. You'll just get bigger numbers. If you choose a denominator that's actually not common, like if you picked 10, then you won't get rid of the fractions. But if you pick 16, it will still work. You'll just have bigger numbers. Okay. The benefit of picking the smallest one is smaller numbers, fewer mistakes. Okay. All right. Okay. So here's what I'm doing. I'm multiplying this in here. Okay. What do I want to cancel that 8 with? The 2. When I cancel the 8 with the 2, what's it going to become? 4. Now here's the thing that's different. You watching? It's 4 times the whole numerator, all of it. All of it. What does that mean I need? Parentheses. It's 4 times 3x minus 1. And you need those parentheses. And that's why I said I need you to see that that structure looks different. Okay? On the right-hand side, I have to cancel the 8 twice because there are 2 different fractions over there. This one is going to cancel. And what am I going to get when I cancel that one? 2. Yes? On the that one gives me 2x. And then this one's going to cancel and not give me 2. And I cancel that one, I'm going to get 1. So that gives me a plain old 3. Does everybody see? Okay? Let's finish that problem up together. Mr. distributive property on the left side. And when we get to this step where we have x's and constants on both sides, we can make decisions about which thing we want to do first. There's 4 different correct choices. We don't have to all pick the same thing. I like to get my variables on the left most of the time, but you don't have to. Oh, that's not right. A bunch of my students in my Algebra 2 class, we keep forgetting to draw this line right there that I just went over, and that drives me crazy. That's why I'm not putting periods at the end of your sentences, right? Like just one sentence after another with no periods. It's hard to read. If you do this and you never draw those lines, yeah, they have to quit because I'm taking points off. But they didn't want to. So drawing those lines is like putting periods. Like this is a change. This is a stopping point. Okay? And there's our answer. All right? We got one more practice together. That's it. And then I'm going to give you your assignment and you can get started. This is a slightly more complex structure. It's just got a few more bits and pieces, but if you can zero in and count the fractions, you're going to be better off. How many fractions are on the left side here? 2. This is a fraction, don't box it, and this is a fraction. It's got 2. How many fractions are on this side? Okay, 1 fraction, and then I can make a fraction out of that. So there's 2 terms over there as well. Okay, so now we're going to look at our denominators, and the biggest denominator is 6. 6 doesn't work, correct? So I think 6, 12, 18. We can count by 6s pretty quickly, and it's going to be 12. Okay, so let's write that step down where we multiply the left side by 12. And the right side by 12. And then we're looking at how this cancels correctly. Got a copy? Okay. All right, let's see if you can get the first step down to the next one, this one. What's going to happen when we do this? Don't say it out loud, write it down. What's going to happen? Okay. Now, what does it cancel to? What are the 12 and the 3 cancel to? 12 with 3 cancel to what? 4. It's not 4 times x, and it's not 4 times 2, it's 4 times x plus 2, and you need parentheses there. Everything? Okay, do the next one. What's that one going to cancel to? 12 and 4 cancel and give you a, yes? 12 and 4 cancel and give you a 3, and 3 times 1 is 3. All right, on the other side, 12 and 6 cancel and give you what? 2. Right there, you're going to get a 2, and 2 times x is 2x, and nothing cancels here because there's not any fractions, and so we're going to get a, so you know what one of the most common mistakes is in all of this, even when you've got that messy canceling going on, is right here. People just put a 1 and they forget to multiply it times 12. It happens all the time because it's so easy they forget to do it at the end. Okay. All right. Now, this is the most complicated one we've had so far. What's going to be a good next step to finish this problem? Distributive property. Excellent. And I like to completely clean up the left side before I start moving things around. Sometimes people will start moving this 8 or moving this 3, but my preference is to clean it up before I start moving it around. So I would just go ahead and add those two together, up at the bottom of my page. 4x plus 5 equals 2x plus 12. Does everybody see where that came from? Okay, don't finish that one on your own. I know, I'm just trying to page. Go ahead and finish this one on your own. It's not everlasting, it's finite. Like all things. Almost all things. When you turn the page and try to remember what I taught. 5. I've already forgotten it. 2x plus 12? Is that right? Okay. So finish the problem. And I'm not going to show every step this time. And I got the answer, x equals 7/2. Okay, now, I have not made you check the answers on here because we've kind of been focusing on doing this without our calculators, but grab your calculator now. We're going to take this answer, x equals 7/2. We're going to check it back here in this original problem. Back here. Carefully typing into our calculators. 7/2 is 3.5, yes? Check that, 3.5? Okay, so when you go to type in 3.5 plus 2 divided by 3, when you have to type it in here, what do you need to put? Parentheses. So type in parentheses. 3.5 plus 2, close parentheses, divided by 3. And then minus 1 divided by 4, and hit enter, and let's see what that says. Okay, you just leave it on your screen. Does everybody get this 1.58 number, please? Have you typed it in? Okay, type it in. Yes. These ladies over here got 1.583 and some more numbers. Yes? Okay, on the other side, you're going to type in 3.5 divided by 6 plus 1. Why does it smell like gum in here? No? Okay. Did you get the same number on the right side that you got on the left side? Yes.
I got 7 over.
That was a previous problem.
Oh.
Yeah. Remember my page ran out? Remember my page ran out?
Oh,
Couldn't go any further, and I had to, yeah. Fix. So the answer was 7 over 2. That's what we're checking. 7 over 2 is the same thing as 3.5. Okay? I just like typing 3.5 better than I like typing 7 over 2. Did it work?
Yep.
Yes, same thing on the left as on the right. Okay? So when you're working these problems, you're going to try to solve them without using your calculator, but you can get your calculator out to check and make sure you got the right answer. Okay? All right. And